Hey Andrew, so I'm just going to walk you through this forecast technique. So the first thing I'm going to do is just do some Earl Barker here. And so if you come on the site, there's all kinds of models. Holy crap. And actually, all of them are useful. But I'm going to just suggest that quickly you familiarize yourself with these here, the NAM radar site overlay and the GFS radar site overlay. What they do is they just take the precipitation forecast from these computer models raw, and they put a temperature algorithm using the 540 line, which is a thickness, and they just predict the amount of snow that will happen by using a very standard ratio. They're not like something I would publish or anything, but it's just a very first glance. So for the next 120 hours, which covers your storm in the Twin Cities, you see that there is effectively no precipitation predicted in your area. But you do see that strong gradient to the south, so I'm going to go ahead and click over here in the glue, and you can see we have a 10 or 12 inch maximum area here along the Wisconsin, Minnesota, Illinois, Iowa interaction here, like very, very small, isolated snow band. And we can go a little farther, like towards Chicago, for instance, and see just how tight that really is. And just to kind of finish looking in Des Moines, you can see, okay, that trend pretty much is a very small storm. So what I'm going to do, we see that, and we kind of have this picture. Okay, this is what the models say raw. I look at the HPC now, and the HPC does lots of things, but I want to bring your attention to two things. First is the quantitative precipitation forecast down here. So like I'm just going to look at days 4 to 5, for instance, which is your time period. And we see that that storm is really expected to kind of intensify as it moves east. And as a matter of fact, we can look the day before and really see that that is the storm's, legacy. Igualmente, we can use a winter forecast program here, winter weather. And what they do is they have a grid here for days 1 to 3 and the precipitation chances of 4 inches, 8 inches, 12 inches of snow. Now, we're still a little out for this probabilistic forecast since, your storm's a little more than 3 days out, but it is starting to eject from the plains here on day 3, so we can see a pretty broad area here of 10% chance of 4 inches of snow, for instance. So these are kind of the professional forecasts, and that's great, and they're sensorial. I mean, you can go and in a minute or two get a quick glance at what the computers are thinking and what the best forecasters in precipitation are thinking and compare it to your local forecast office, and that's pretty strong stuff. But I mean, really, when you're making forecasts, you're more interested in using data. I mean, it's no fun just to see what other people say. So I want to go ahead and use the Twister data here. And Twister data is by far the best website for this kind of stuff. I'm going to be using the GFS run because your time period here is still 4 days out or so. So that's a little too far out for, say, the NAM, the medium range model to work. Right now we're getting new data in, as you can see by these reds here. So I'm going to just knock us back 6 hours to the last model that has full data. And here we have a nice global temperature or continental temperature. We can see that we have a nice occluded low sitting off the coast here. We have the low that's producing the quick light snow flurries across here and making it very cold where you're at, and a nice temperature gradient here across the middle United States with a nice wind shift here. So probably have a nice front, and you can see that it would follow this kink in the isobars, however settled it is. And so we do the front there, just kind of taking a quick glance at things. And that's really the big thing here. So just using this, again, like I wouldn't make a forecast for myself this way, but it's a good way to start off learning, is I'm just going to go ahead and click the 6-hour cumulative precipitation here and see where the computers think it's going to precipitate, because in the end, that's what's interesting to us. I come up here and animate it. And wait for my computer to load, and it will take a bit of time. And then here it comes in the model run, and there's our storm. And then later in the model, we get to the lower resolutions here at the end, where it's going to block out them because the model forecast every 12 hours instead of every 6. So just stepping through, we see that the storm begins to have a nice long linear kind of hot dog shape here along the front. And also we can see this moisture feed up from the Gulf. And just coming 6 hours later, we can see that forms into a much more mature looking kind of comma head shape. Right now also we can see like the low, which would be sitting between the front and that comma head, would be centered here over like Cape Girardeau, Missouri, or Actually, Cape Girardeau's down here. I don't know, central Missouri Ozarks. And we can kind of track it and see that that low tracks here towards like South Bend and becomes pretty mature. And as it ejects, kind of, spreads out a bit, but still produces quite a large snow event, especially as that comet head detaches over the Hudson Bay area up there in Canada. So there's your storm, kind of lived out. Just rock through it here a few times. So it's pretty clear that there's a very rapid intensification. 6 hours we go from this linear system to a relatively comma-shaped system. I mean, and that right now is happening at 0Z on Thursday to 6Z on Thursday. So really about midnight Wednesday. By midnight Wednesday, this is hit. And so in a snowstorm, we'd be interested in this comma head up here for producing snow. Of course, with snow, we'd be interested in air temperatures. So just a quick glance at surface temperatures. Is this precipitation falling in 40-degree weather, or is it falling in, is it falling in 50-degree weather? Well, or is it down in 20? And where exactly is that surface low tracking? We kind of derived its position and interpolated by using the precipitation forecast, but we didn't really get there by looking at the actual data. So here it is, and we can see, well, that didn't quite work out so well. Our low is actually centered down here, not in South Bend, but actually over like Springfield, and it's a significant distance. But for a first glance, we weren't doing too bad, and we can see that track nicely over the Panhandle region, actually over towards the Little Four Corners, up into Springfield, and ejecting eventually and deepening significantly as it occludes. A very strong storm, very, very strong storm, right? And quite impressive. And you can see the southerly flow here, this moist tongue coming up from the Gulf. You know that's going to be moist air, and you can see this very strong cold front sweeping down behind itself too. And one thing to note now, this is the 6Z forecast again. So when that precipitation was nicely comma head, we do have temperatures that would be indicative of snow. The question is, why is this happening? I mean, it's interesting to see the models say that. And so to look at that, I'm going to just quickly glance at the upper level winds, the jet stream winds, which are pretty straightforward to read. You're looking for big dips called troughs for storms and jet streaks and how those two things interact to really forecast your storm. And so we're going to wait for this model here to run really fast, or at least render these things for us. There they go. All right. So here we have 3Z on the 18th. Tuesday. Wednesday comes through. Here's our low, kind of there. And I don't know why I just skipped backwards. All right, there comes our storm. So we see that we have. Wait, this is very much the wrong storm. This is the storm I'm very interested in for later in the storm. My apologies. It's like, wow, that really got impressive in the last model run. No kidding. Forgot I was looking at the GFS. So here's our storm coming in over Nevada. If we watched it a little longer, we can see it eject with this very broad jet streak over the Great Lakes region and a weak jet streak here coming out the base of the trough. But as it ejects, it kind of laminarizes a bit. And here now we're looking. Okay, I don't know why it's not letting me look. So, valid on 6Z Tuesday. Sorry, this is what happens when you have a rough forecast discussion. Here we are. Here's our storm as it would be at its peak intensity for your area. We see the upper level low is way back here over Nebraska. And remember, our lower level low, our surface low, is over Illinois. So we can see that with height, the low tilts backwards. That's what we call baroclinic, or developing. That this is a storm that's still getting stronger. This is a very good thing from a snow producer. Unfortunately for you, both tracks are relatively, south for Minnesota. You want to be kind of right on the edge of that comma head. And we can see this broad jet streak, which if we, diagnose down, we know that we have upper level divergence in this area, and so we would have the synoptic scale lift under there, which would support the low too. And, if we go down here and we look at, well, where's the twist in the atmosphere? Because obviously the low is going to rotate. We're going to use something called vorticity. And this is going to track our storm. And these are the winds at the storm level that would help us forecast. And this is, again, for when that storm's organizing. And you can see there's like these bands of vorticity in here. And my guess is if I step forward a couple times, they'll organize quite a bit, especially this back area here. And yeah, you can see how that, in the next run, even the trough here over central Iowa is just a lot cleaner looking. So, I mean, this is the storm still getting its act together as it's already well past your area. And as I said, it's going to turn to a kind of a major snow event, later on as that storm low occludes. But right now, you're not interested in that. You're interested in, forecasting for your immediate area. And we can see that storm really, you have this nice warp max associated with the low. And you can see this trough really nice and smooth where, like, over the mountains here, it's sawtoothed. It's air from the mountains and some, like, approximations that would come from that. So, I mean, and again, this should diagnose very nicely our baroclinically tilted trough, because you can see the upper level low in the mid-levels of the atmosphere is also quite a bit far back. So we know that it was tilting westward with high, just baroclinic. So all that seems pretty interesting, and just a kind of a quick way of checking this are two parameters here under winter. One of them is the 1,000 to 500 millibar thickness and a plot of surface pressure. So what I'm doing here is I'm looking for a line that's called the 5400 line, which is the difference between blue and green here on this temperature scale, because the people who made this knew what they're doing. And so the 540 line is 540 decameters. So from the surface to this height in the atmosphere, it's going to be 5,400 meters. And that is a magic number. That's the rain snow line empirically. I mean, it doesn't always play out that way, but the 5,400 line tends to be where the rain to snow transition happens. And as our storm was starting to show that peak definition again, you see that line, the rain snow line, right along this area here. And if we come forward just a little bit, we see that rain snow line pretty strongly here. But again, we didn't see the QPF forecast in Minnesota. We saw the low track, and it seems to make sense that we'd have precipitation, that the ingredients are in place. And we see that, well, this area is, pretty prone to snow. So remembering where that stuff is, let's just look at where the snow fell in those 6 hours. Where rain fell in those 6 hours. Now we're just trying to get a better picture. And we say, all right, this area up here seems to really definitely be snow without a question. But just to check it, let's take a look at what the atmosphere does vertically. And so what I'm doing here is just launching a weather balloon with the model. And so I'm off here kind of close to Madison. So not our heaviest snowfall forecasts from that model output, but close enough. And so we see the 0 degree line here. And all the way up, our lines never cross that. So everything that would fall in this area is going to fall below freezing. So, I mean, this is one of the most complex charts you're going to look at. It tells you so much about the meteorology that's going on here. But right now, just sensorially, we know that anything falling is going to be snow. Whereas, let's say we came down here and plotted a sounding in central Illinois, right on the edge of that 540 line, right? Well, you're going to see that why this would be a little harder to forecast, hopefully, if I chose. Yeah, so this is actually really cool. So here we see there's surface temperatures right at 0, but up here there's this nose that's like right close to 0 again. So if precipitation were to fall here, it might fall but melt and then refreeze. And so this sounding here might suggest, hey, maybe this is sleet. And if I came down here to southern Illinois, kind of right past the 540 line with a lot of no doubt at all, what we're going to see is that, well, the temperature is well above 0 at the surface, and so everything that falls is going to be snow. And sure enough, there it is. So it's kind of just you got all that. And in a final way, I mean, I wouldn't recommend doing this, but the GFS does produce a map of snow depth, total snow depth, so storm accumulations on top of what's already on the ground. And we can see, at the end of this storm, kind of the track this had. And so you can see kind of the snow track here from this storm, which we can kind of deduce by just looking at the pre-storm conditions, which looked about like this. Perfect. So I mean that's your sign. Obviously you've got this going to this. And that's really about it. I mean, is that a great way to forecast snow? Nah, we didn't do anything with like isotropic charts. We didn't do anything with like cross-sectional analysis or megas. We didn't really talk about how we'd get snowfall totals out of this, how we'd forecast, well, where are these bands going to set up? And right now we're really just interested in where is the big area of snow going to fall. And right now the low track and the storm track and the development time frame both suggest that the storm will not really get its act together until it's past you. And right now, even if it had its act together when it was going over you, it's still south. And so for this storm to impact your area, we'd want the storm to shift north a couple hundred miles. It's not all that impossible. And also develop more quickly, which is a little less likely. So, I mean, is it a storm worth watching? Yeah. Is it an interesting storm? Well, I mean, if you're in this area, you're looking at an 8 to 10 inch storm. That's significant. And, obviously a small shift southerly, which is not impossible, would impact a major metropolitan area in Chicago, which has just broken their record for the longest consecutive days without snow. So that's insight. It's not everything, but it's something. So hopefully that helps you learn. Bye.